circles and four-sided figures. We touched on a little bit of it yesterday, but now we're going to go more into depth. So let's think about circles. Now, we've talked a lot about circles in the past. Now, I got a soccer ball. Anyways, how many degrees is a circle or a soccer ball? Even though my soccer ball is a little egg-shaped right now, it is 360 degrees. If I cut it in half, what would it be? It'd be 180 degrees. Now, what is the straight line that we call that goes right in the middle of a circle and it starts from one side of the circle to the other side of the circle? What is that straight line called? It is called a diameter. If we just took the straight line out, what would the straight line angle be? It would be 180 degrees. Another figure other than the straight line being 180 degrees that is also 180 degrees is a triangle. There are different kinds of triangles, but they all equal 180 degrees. Now, some triangles that we probably want to know more about is an isosceles triangle, which an isosceles triangle has two equal sides to it. Each opposite angle is the same measurement. An equilateral triangle, all sides are equal. All sides are equal. And all angles are equal. So if we have all angles being equal, and we know that a triangle has to be 180 degrees, what will one angle be of an equilateral triangle? One angle of the equilateral triangle will have to be 60 degrees. Another important part we need to know is an exterior angle. An exterior angle we can see on other figures, but we usually primarily can see them on a triangle. And an exterior angle is equal to the sum of the interior opposite angles, shown in this picture right here. An exterior angle is on the outside of the triangle or outside of the shape, while an interior angle is inside the shape. That's the difference between them. Another shape that we need to talk about today is a parallelogram. A parallelogram is a four-sided figure with two pairs of parallel lines. The parallel sides are equal in length. So the sum of each pair of angles between two parallel lines is 180 degrees. Okay, now let's look at page 62 of our textbook. Get it out.
In the figure, ABCE is a parallelogram, CDE is an equilateral triangle, and BCD is a straight line. Looking at the textbook, we need to find angle P, angle Q, angle R, and angle S. So let's do it.
So it's been a long time since we got our smart board, so let's do that today, okay? Let's go.
Since I kind of want to work with the picture in our textbook, I'm going to copy and paste this picture really quick and put it on the smart board. Since the direction said CDE is an equilateral triangle, I know that angle P will have to be 60 degrees because every angle C, angle D, angle E will be 60 degrees. Knowing that angle P is 60 degrees, I know angle Q plus angle P equals 180 degrees. I already know angle P, so I'm going to replace angle P with 60 degrees. Now, angle Q plus 60 degrees equals 180 degrees. To get angle Q, I'm going to subtract 60 degrees from both sides. That leaves me angle Q by itself on the left side equals 180 degrees minus 60 degrees, which gives us angle Q equaling 120 degrees. When I got angle Q, I know that a parallelogram, the opposite angle is the same angle measurement. So angle R will also be 120 degrees. That leaves me angle S. Now I can see that angle S plus angle R is going to equal 180 degrees, and I know that angle R is 120, so 180 minus 120 gives us 60 degrees for angle S.
Okay, that is it for our lesson today for 5.1a. We were finding unknown angles specifically within a triangle and